Welcome to the session. Today we are going to see auto differentiation. So it is very much important to understand this concept, to understand how the learning phase or the training phase is happening in the artificial neural network. Okay, so we have to recap the chain rule in order to understand the auto differentiation. In calculus, the chain rule is a formula to compute the derivative of a composite function. Okay, suppose we have a function called f for which the input is another function g and g is a function of x. Okay, so if you want to find out the derivative of this function with respect to x, what we have to do, we have to find out df by dg, that is f is depending on g. So we have to find out the derivative like this, df into df by dg into dg by dx. Okay, suppose we have another function like this, g of h of x. Okay, so g is again a function of h and h is another function which is taking x as a parameter, okay, as the argument. So in this case, how do we find out df by dg? Df by dx. Okay, that is the ultimate variable is x. All the others are the functions. So df by dx. How do we find out? First, we have to find out the derivative of f with respect to g. Okay, so that is df by dg. We have to calculate into. Then we have to find out the derivative of g with respect to h. So we have to find out dg by dh. Then we have to find out the derivative of h with respect to x into dh by dx. So that is this. It's actually a recursive thing. It goes like this, and if we have any number of composite functions, we can follow the same thing. Okay. Then another notation for this chain rule is Leibniz notation. Variable, it is defined in terms of variables. Okay, so if we have a variable z that is depending on y and y is depending on x. Okay, so here z and y are the dependent variables and x is the independent variable over here. And if you want to find out the differentiation of z with respect to x, how will you do? So that is dz by dx is equal to, first we have to find out the derivative of z with respect to y, because z is actually depending on y. So it is dz divided by dy. Then we have to find out the derivative of y with respect to x. So it is dy by dx. Okay, that is the Leibniz notation. Then what is auto differentiation? It is automatically this automatic differentiation, or we call it as auto diff. That is the common term we use in machine learning. It is a set of techniques to numerically evaluate the derivative of a function. Okay, that is, it is numerically evaluating the derivative of a function for a particular point. Suppose we have a function f of x is equal to x square, and what the auto differentiation gives is, suppose we want to find out the derivative of this function when x is equal to 10. Okay, so this, its numerical value will be given by this auto differentiation. Okay, what is f dash x at x is equal to 10, or what is f dash x when x is equal to 15. Okay, that numerical value will be given by this automatic differentiation. It will not give you any common or general formula like 2 into x for f dash x. It will not give you like that. It will give you the exact value of 2x when x is equal to 10 or x is equal to 15, like that. Okay, so it's a numerical method. Then we use reverse mode auto differentiation. There are two methods. One is forward mode auto diff and reverse mode auto diff. So in back propagation, what we use is reverse mode auto diff, and back propagation is a step in training of the neural networks. Okay, and what back propagation actually doing is, it is updating the weight of the neural networks. Okay, So that is in back, we will see in detail in back propagation session. Okay, so reverse mode auto differentiation is used in back propagation. So reverse mode auto diff is suitable when we have a function which takes n inputs and produces a single output. So reverse mode auto diff is more suitable for a function with the multiple inputs and the single outputs. Okay, some real value, some single value output. Okay. Then the dependent variable to be differentiated is fixed, and the derivative is computed with respect to each subsection recursively. Okay. Okay. So what we find is a dependent variable to be differentiated is fixed and the derivative is computed with respect to each subsection recursively. So we have the dependent variable y and the independent variable x. So how do we so we can find the derivative, partial derivative like dou y by dou x. So it is given like dou y by dou w1 into dou w1 by dou x. And this dou w1 can have more components inside it, or it can be a composite function, or it has many inner components. So this term we can again expand like this. Okay, so our dou y by dou w2 and dou w2 by dou w1. Okay, so that means that y is depending on w2 and w2 is depending on w1. Like that we can expand these terms. Okay, so again this term can be again expanded like this, dou y by dou w3 and dou w3 by dou w2, like that. So this kind of recursive expansion is possible here. Okay, and automatic differentiation is well suited for these kind of functions. Okay, so let's see an example for auto differentiation. Okay, so it uses graphical computation method. Okay, graphical computation, that means if we want to evaluate a function, first the function will be represented in a graphical form, and that graphical form will be evaluated to find the answer for the function. Okay, so assume we have a function like this. It's a multivariate function f of xy is equal to x square y plus y plus 2. Okay, so this is our function. Okay, and we want to find out the derivative of this function when x is equal to 4 and y is equal to 5. Okay, so that is the thing we are going to do. So first of all we are going to construct a graph that represents this function f of xy. Okay, so here basically we have two variables x and y, and one constant over there 2. Okay, so we create 3 nodes corresponding to these two variables and the constant. So here x is one node and y is another node and 2 is the third node, and we name them as n1, n2 and n3, and assume x is equal to 4 and y is equal to 5. That is the case we are going to check. Okay, so we are going to construct this function. How do we take x square into y? So we have to find out x square. So how do we find out x square? That will be x into x. So we add a multiplication node over here, and like this. So this is n4, node n4 is the multiplication node, and there are 2 arrows from this x. That means it means x into x. So that will give you x square. Okay, so it is x into x square, and this x square has to be multiplied with y. Okay, so we will add one more multiplication node like this. Okay, n5, that takes x square into y. Okay, and now we have to find out this term y plus 2. Y we have here and 2 over here, and add a summation node here to add the add y and 2. Okay, y plus 2. So this is n5 will give you x square into y, and n2 will give you y plus 2. Now we have to add these two terms. Okay, so add one more node to find the summation of this x square y plus 2. Okay, and its final answer will be 87, because okay, here x is 4 into 4 is 16, then 16 plus 5 16 into 5 will give you 80, and here 5 plus 2 will give you 7, then 80 plus 7, 87 is the final answer for the function at x is equal to 4 and y is equal to 5. And now we want to find out the derivative of this function at this particular point. That is, we have to find out f dash 4, 5. Okay. Okay, then if we find, if we do it manually, what is f of x, y? That is, we have to take the partial derivative since we have multiple variables over here. So what is dou f by dou x? So keeping y as the constant, it will be 2x into y. Okay, the other terms are 0. It is 2xy. So 2 into 4 into 5 will give you 40. So dou f by dou x at x is equal to 4, y is equal to 5 is 40. Then what is dou f by dou y? Keeping y as the variable and x as the constant, it will be x square plus 1. So 4 square plus 1, that is 17. Okay, so 17 and 40 are the answer for the partial derivative at 4 and 5. Okay, x is equal to 4 and y is equal to 5. Okay, so let us see how it is done in auto differentiation. So we consider the same graph. This is actually the graph that represents the function, and when we go for auto differentiation, we just reverse the arrows in the reverse order. Okay, that is, it is like this, from the output to the input session. So this is the output part, and this is the input part. Okay, we have the x and y as the input. Okay, so now we are going to evaluate the derivatives from this level to the downwards. Okay, from output to input. That is why it is called the reverse mode of auto differentiation. So we are going to start from the output side and start derivation, and we will do it recursively to reach the input session here. Okay, so we will start from here and will finally reach dou f by dou x over here. Okay, like that. And now we are going to start a derivation from this node n7. Okay, so we have to find out dou f by dou n7. Okay, so since f is this one, f is 87, and the basic concept is like this. For the output, for the final node, always the derivation will be 1. Okay, dou f by dou n7, it is always taken as 1. And from this derivative, we have to calculate the derivative of n5 and n6. Okay, we are going to evaluate the derivative of n5, or dou f by dou n5. Okay, derivative with respect to n5 based on its parent's derivative. Okay, if we know the derivative of its parent, we can find out the derivative of n5. And how do we do it? The concept is like this f, output function f or output value is depending on n7, and the value of n7 depending on n5 and n6. Okay, and the value of n5 is depending on n4 and n2. Similarly, the value of n6 depends on n2 and n3. Okay, it goes like that. Okay, so that means if we change what is dou f by dou n7, if there is a small change in n7, what will be the change in f? Okay, that is meant by dou f by dou n7. Okay, since the output of n7 is equal to f, when n7 changes, that will be reflected in f as such. So that is why it is 1. Okay. And now we have to find out dou f by dou n7. That means that if there is any change in n5, how it will be reflected in f. Okay. So this is equal to, how do we calculate it is, we first find out the derivative of f with respect to n7, its parent. Okay. A parent of n5 is n7. So the change in n7, how the change in n7 reflects in function f. Okay, that is dou f by dou n7 into dou n7 divided by dou n5. Okay, the change in n5 will affect n7 also. Okay, so that is the relation. F is depending on n7 and n7 is depending on n5. So that is it. So we know the value of this one. In the previous step, we have seen the value of dou f by dou n7 is 1. And we have to find out dou n7 by dou n5. Okay. So to find out dou f by dou n5, we have to find out what is dou n7 divided by dou n5. Okay. So the other term got it is only 1. So it has no effect there. Okay. And what is n7? N7 is actually the sum of n5 and n6. So we can rewrite n7 as n5 plus n6. Okay. By dou n7, n5. Okay. And in this derivation, this is taken as a constant. N6 is taken as a constant. So what will be the answer? It will be dou n5 by dou n5, and that is equal to 1. Okay, so dou f by dou n5 will be equal to 1. So I will write it here. Okay. So this is dou f by dou n5 is 1. And the same way we have to find out dou f by dou n6. So what is dou f by dou n6? It is dou f by dou n7 into dou n7 by dou n6. Okay, so this term is 1 as we found it in the previous step 1. And this is dou n7. We have to replace dou n7 with the n5 plus n6. So it is equal to dou n5 plus n6 divided by dou n6. So that means this is a constant. The other term will be equal to 1. Okay, dou n6 by dou n6 will be 1. Okay, so these three terms are 1. Now we have to find out dou f by dou n4. Okay, so that means it is equal to dou f by dou n5, its parent, into dou n5 by dou n4. Okay, and what is dou f by dou n5? This term is 1. Okay, that's we have calculated in the previous step. And dou n5 by dou n4. What is n5? N5 is actually n4 into n2. Okay, so how do we calculate dou f by dou n4? Dou f by dou n4 is equal to dou of n4 into n2. Okay, sorry. And n4 into n2 divided by dou n4. Okay, that means n5 is replaced like this. N4 into n5 is actually equal to n4 into n2. So that is replaced here. That means n2. This is equal to n2. N2 is nothing but y. Okay, and what is the value of y over here? It is 5. So this value is equal to 5. Dou f by dou n4 is equal to 5. And next we have to find out dou f by dou n2. Okay, dou f by dou n2, or n2 is actually y, so we can replace it with y also. And what is dou f by dou n2? It has two parents, n2 and n6. Okay, So we have to find out it like this. Dou f by dou n2 is equal to, it will have two terms. One is dou f by dou n5 into dou n5 by dou n2. Okay, that is this node, and we have to consider this n6 also. So we sum up it, dou f by dou n6 into dou n6 by dou n2. Okay, so what was dou f by dou n5? It was 1 into dou n5 by dou n2. Okay, so dou f is actually n4 into n2 divided by dou n2 plus dou f by dou n6 is 1 into what is dou n6 and what is n6? N6 is n2 plus n3 divided by dou n2. So what is it? It is actually n4 plus 1, that is n4 plus 1, that is x square plus 1, that is equal to 16 plus 1, 17. Okay, that is this value, dou f by dou n2, we can also call it as dou f by dou y. Okay, since n2 is representing y, it is equal to 17. Okay, and what is dou f by dou n1? Dou f by dou n1, or in other words, it is dou f by dou n1, which is equal to dou f by dou x. What is dou f by dou n1? Okay, dou f by dou n1 is equal to dou f by dou n4 into dou n4 by dou n1. Okay, what was dou f by dou n4? Dou f by dou n4 was 5 into what is n4? N4 is n1 square. Okay, so dou n1 square divided by dou n1. So what is it? 5 into 2 into n1. And what is n1? N1 is x. Okay, that is 10 into x, that is 10 into 4, which is equal to 40. Okay, so what we got is dou f by dou x is equal to 40. Okay, so we got the final answer of this one like this: dou f by dou x is equal to 40 and dou f by dou y is equal to 17. That is the same answer we got manually. Okay, so in manual calculation we got the same answer, 40 and 17. Okay, so this is the how we evaluate the derivative of a function in reverse mode autodiff. Okay, so what is the advantage of this step? If we know, even with the local computations, we can find out the derivative of a function. If I want to find out the derivative of this one, I just want to know the derivative of the previous one. That is enough. I don't want to bother about the other data, or I don't want to bother about the other branches or the other session or the other subsession of the graph. I just want to know its parent. Okay, so that is the advantage. So even without loading the entire data into the data set itself, I can find out the derivatives. That is the advantage. Okay, so that is reverse mode autodiff. So this is the final answer. Dou f by dou n7 is 1 and dou f by dou n5 is also 1. Dou f by dou n6 is 1. Dou f by dou n4 is 5. Dou f by dou n2 is 16. It is a summation. Dou f by dou y is equal to 17. Okay, 16 plus 1. We add up these two terms. Then dou f by dou n1, which is equal to dou f by dou x, is equal to 40. Okay, so that is the answer. So we can just cross check it with the manual evaluation. So dou f by dou x is 2xy. So 2 into 4 into 5. That will give you 40. So the same answer we got here. And dou f by dou y is x square plus 1, that is 4 square plus 1, which is equal to 17. So the answer we got here. Okay. So we can confirm that this autodiff will give you the same answer as that of the manual evaluation. And that is it. That is all about the auto differentiation. And thank you for watching.